All right, section 2.6 is dealing with what's called related rates, and the definition that I have there with related rates is that it's the rate of change of two or more variables that are changing with respect to time. So how is the volume of something changing over a period of time, or how is the area changing with respect to time, or the distance of something? So when it says that you have two or more variables, that could be, like I said, the distance of something is changing, or the height of something, or the volume of something. But how are these changing in reference to time, or with respect to time? Of course, when you're talking about the rate of something, you're looking at how fast is it changing. Okay, here is a list of steps that you'll need to write down. So just kind of running through these real quickly. It says to identify all given quantities and quantities to be determined. So I always write down my given and what I've got to find. So you'll see me do that with each problem. So then you're to write an equation involving the variables whose rates of change either are given or are to be determined. Sometimes they'll give you the equation, but if you're talking about the area of something change in the area of a circle, then your equation is going to be the formula for area of a circle. Or if you're talking about the volume of a cube or a rectangular prism that's changing, then you're going to use your volume formula. You'll see that we'll use Pythagorean theorem on some of these. So sometimes the equation is given, and sometimes you just have to recall things that you have already been exposed to in the past. All right, step 3, using chain rule, implicitly differentiate both sides of the equation with respect to time. Of course, t is going to obviously be the variable that they're going to use here for time. All right, so thinking back to the previous section where you just first learned how to do the implicit differentiation, you had to do that with respect to x each time. So therefore, whenever you were doing the derivative of something involving x, you just did it as normal, and everything else we had to tack on the dy dx. But this time, you're going to do it with respect to time. So like what you're going to have on the bottom is dt. So anything involving t, will be done as normal. All right, step 4, substitute all known values for the variables and their rates of change, and then solve for the required rate of change. Basically, once you get through step 3, this is just substitute in what you know and then find what you're supposed to find. You just basically end up solving an equation when it comes to step 4. All right, the first few examples that we're going to do are not related, to any type of volume or area, just what I would refer to as just generic problems, just getting you used to the process. All right, so it says suppose x and y are both differentiable functions of t and are related by the equation y equal x squared plus 3. Find dy dt when x is equal to 1, given that dx dt is equal to 2 when x is equal to 1. Now, they've stated here twice that x is equal to 1. Sometimes you'll see that they'll state things twice. Okay, so when I'm talking about given and find, all right, so my given information, I am given that dx dt is equal to 2. So dx dt is equal to 2. And the other information that I'm given is that x is equal to 1. Like I said, just write down what you know. Pull that information out of your problem. Okay, now what is it that I've got to find? Okay, it wants you to find dy dt. Of course, in this problem, everything is easily identified. It just comes out and tells you, here's what you know, here's what you've got to find. Sometimes you kind of have to think about it. Sometimes it's just not written very obviously. So we've got to find dy dt. All right, now you had the step where it said to write an equation. Your equation is given to you, like this equation, y equal x squared plus 3. This is given to you. That's the equation that relates your x and your y. Okay, so not anything that we have to come up with on our own here. I said this is just getting you used to the process. All right, step 3 is to do the implicit differentiation with respect to time. Okay, so that means dt on the bottom. Of course, you notice in both situations here we have dt. So that means when you're taking the derivative of a t, you do it as normal, and everything else you have to throw on, you know, the notation of dy dt or dx dt. All right, so the derivative of y, of course, would just be 1, but this is not a t, so that means this would be dy dt, because you're taking the derivative of a y with respect to time. Okay, now x squared, of course, using your power rule, you would have 2 times x. But again, this is not a t, so that means you have to apply the chain rule, and you've taken the derivative of an x with respect to time. So you have to tack on the dx dt. And of course, the derivative of 3 would just be 0. Okay? All right, now there's step 3. Step 4 is to substitute in all known values. So we know that dx dt is 2 and that x is equal to 1. So we substitute these values in. Of course, we're trying to find dy dt, which dy dt happens to already be on one side by itself, so there's no need to move anything around. So I replace x with 1, and dx dt is equal to 2. Therefore, dy dt is equal to 4. So like I said, this is just a generic problem. I mean, it'll make more sense to you know when we actually start talking about, you know, actual situations. But this is just getting you used to the process. Now, one problem or one thing that I see students do sometimes is like when you're given values like this, like x equals something, y equals something, sometimes they may give you radius, you know, and you want to substitute those numbers in like way back up here at the beginning. There are going to be a few situations where you can substitute these in at the beginning, but most of the time you can't, okay? So, and that's one thing I'll make a big deal out of and make sure you know the difference a little bit later, but most of the time you can't. So I don't want you thinking, well, why did she just not plug the 1 in to begin with? You can't. When we get to a real life situation, it'll make more sense. Okay, here's another one that's just, again, just kind of like a generic situation. Okay, again, suppose x and y are both differentiable functions of t and are related by the equation xy equal 8. Okay. Okay, so what am I given? All right, so I am given that dx dt is equal to 18. And I'm also given x is equal to 16. Like you're wanting to know this rate of change of y when x specifically reaches 16. But again, you cannot plug that 16 in just yet. All right, so what we're trying to find, again, we happen to be finding dy dt. Okay, the equation is given to us again. We have the xy is equal to 8. All right, so we're taking the derivative, remember, with respect to time. Now this left side is going to require that we use the product rule. So first function times the derivative of the second. Well, the derivative of y would be just 1, but then you'd have to do dy dt. plus second function times the derivative of the first function. So the derivative of x would be 1, but then you have to apply that chain rule and you have dx dt. So you're taking the derivative of an x, but with respect to time. And then that would be equal to 0. Derivative of 8 is just 0. All right, now you can substitute in what you know. We know that x is 16. Now, we don't know y, and we'll discuss that in just a second. I'm just going to leave parentheses open here for just a second. And we know that dx dt is 18. Now, if I'm trying to find dy dt, that can be the only thing in here that I don't know. Like, I have to have a value to substitute in for everything else except for what I'm asked to find. So there's got to be a way that I can come up with a value for y. And that's actually going to go back here to the original equation that's given to you. So we have xy is equal to 8. Now, I'm looking at this rate of change specifically when x is equal to 16. So if I were to substitute 16 in for x, then this is going to give me an equation that I can solve for y. So what I'm doing is finding the y value that belongs to the 16, to the x value of 16, specifically at this time. So then I would get y is equal, to, of course, to 8/16, which reduces to 1/2. Okay, so that means back to my equation, I can replace y with 1/2. Like I said, you start plugging everything in. The only thing that you are not supposed to have a value for is what you've stated here that you're trying to find. Okay, so I have 16 dy dt. Of course, 1/2 times the 18 is going to give us 9. And then I'm going to subtract my 9. And divide by 16. So dy dt would be equal to negative 9/16. Okay, now you're talking about a rate of change. The fact that that comes out to be negative, that would just indicate that there's something, for instance, that's decreasing. And that's one thing. Again, when we start looking at these actual situations, there's going to be times that we need to remember to make things negative. With the fact that it's decreasing, and you keep things that are positive, that are increasing.